Hello, welcome to Tom's Trains. Today we're going to be looking at how to build a gearbox for a kit locomotive. It's one of the great advantages of building your own kits is that you can customise the gearboxes. What I mean by that is if you're building an express locomotive, you can build a gearbox to make the locomotive go really fast, and if you're building a freight loco, which might do quite a lot of shunting, you can customise that gearbox so you've got really good low speed control, and it also gives it a bit more power as well. So what we're doing today is a high-level kits gearbox and a Mishima motor. The Mishima motor, I think it's a 1428. Little 1428 motor. Nice and powerful, about 15,000 RPM, and the gearbox itself is about 60:1 gear ratio. So with the wheels that I have for the LNER J3, that should give it a scale speed of about 30 to 40 miles an hour. The link to High Level Kit's website is in the description below. On that website there's a really good speed calculator to enable you to choose what motor you want, choose the gearbox, and it gives you a scale speed. So it gives you an idea of what you're achieving with that gearbox and motor combination. There's lots of information on Chris Gibbons' website there on High Level Kits on how to choose a gearbox, and if you are unsure, I'd say that's a really good starting place because Chris is really helpful. So just give him a call and he'll get you on the right track if you haven't built a gearbox before. But today we're going to be building this little guy, and we'll get straight to the workbench and have a look and see how it's done. We're nicely set up now at the workbench, and just open up the packet for the High Level Kits gearbox. This is what you get inside. A nice set of instructions like so. Really nice drawings and also some notes as well, and then you get the gearbox bits itself. So that's the main component there, that's the fret that everything else is based off, all the gears there, and a couple of, this is like a steel shaft and a bit of brass as well. So let's just tip these bits off onto the workbench. We want to keep those bits safe, especially this little worm gear here. Don't know if you can see that. Tiny little thing, goes missing quite easily, and I'm just going to put those bits that I don't need right now back into the box. Back into the bag. That is a bag, not a box. So there we go. Leave one of those out because we'll need that in a moment. I'll explain why. Okay, good. So the first job on the fret here is to open up the holes. Now, when you're opening up holes in etched material, the first thing to do really is to check to make sure that the hole is actually requiring opening up. There's no point going in with your tools, making the holes bigger, and then finding out you've got too big clearance. What we're looking for is really like a push fit, so that it just, whatever you're putting into the hole just fits snugly in without any sort of side play. So this is a 2mm shaft, and these holes here all need to be opened out to 2mm. Now I checked before, I know that this doesn't quite fit, but there we go, you can see that just doesn't fit in there. And what we're going to do is open that one up, and also the axle as well, for the axle bearings. That's this little chap here. Let's see if I've got some tweezers. No, I don't, can't see any. Anyway, so that needs to go in there like that, but again that doesn't fit. And the third one that we have to do is these little holes here, just on the edge of the fret there, like so, and they need to be opened up as well. So all we need to do is grab one of these. This is a tapered reamer. Was it a tapered reamer? No, cutting broach. Sorry, this is a cutting broach. Tapered reamer, I'm getting mixed up with something else. Cutting broach here, and I just fit it into the pin vise, and all I do, just leave these on the fret. It's much easier to open these out when they're on the fret. Go in there like so, and just gradually start to twist in there like that, opening up the hole, and just go slowly. Check, see that's almost there. Literally just those 2 or 3 turns, and that's almost there. A couple more turns, just opening that up like so. There we go. That's it, done. Don't, whatever you do when you're opening up holes in etch like this, don't use a mouse tail file, because all you'll do is make it round. You'll make an oval sort of shape. It won't fit properly. So yeah, don't use a mouse tail file for this sort of thing. Once I've finished opening up the hole, I just give a light brush over with the file just to remove any burrs like that. You can do that while that's all on the fret. I've opened up all the holes now on the fret itself and checked everything against the components to make sure it all fits in. One thing I did forget to talk about earlier on is on the end of the motor here there's a little neck just where the shaft of the motor goes into the body. Just check that one against the fret as well, just to make sure that goes through. It does. These are all, I think these frets are designed for these particular Machima motors. I did have one before. It was a round can, one of the old type round can motors, and that didn't fit, so I had to open up that hole. But I think most of the standard Machima motors do actually fit the fret. So having opened up everything else, we can remove the gearbox pieces from the fret itself. You can either use some of these are Xuron cutters designed specifically for photo etch, or you can use a Swan Morton scalpel. Either's fine. I'm just going to use the scalpel, it's fine to do so. And when you're cutting etch, this is nickel silver I think, but always do it on a hard surface, because if you do it on a cutting mat like this, you'll actually distort, or you're liable to distort the metal work. You can also use something that's really good is like a piece of what's it called? Not acetate, like PVC or some sort of hard plastic. I can't remember the name of it. I'll put it in the subtitles. Anyway, I'm rambling. There's one piece that there's one thing that you mustn't remove, and that's these little parts here. There's two little tabs on either side of the gearbox. They need to remain on there because you use that later on for making everything square. So I'll go ahead and remove these bits from the frame now. Next job is to solder these axle bushes onto the spacer unit, and you just need to make sure that the bushes go in on the top, so they'll be like in that sort of orientation with the etched fold line there on the top. So the best way to do this is obviously fire up the soldering iron, about 360 degrees is fine, standard 145 solder, turn the unit over, put both of the axle bushes in like so, so you can kind of press it down. Then, of course, in with some flux, always using flux on this, like so, and then get my solder, clean off the iron tip, bit of solder on there like so, and in, and solder, and you're looking for the solder to flow right the way round, like that. Wait for it to solidify, and then same on the other side. You do get hot fingers, but you'll get used to it, don't worry. That's really hot. Ah! You've got to hold it a little bit longer than you think, because otherwise it will just come loose right at the last moment. So when we turn this over, what you should have is a nice soldering right the way around like that, and that ensures a really good joint. The next thing we're doing is forming up the stretcher and the gearbox itself. We need to fold those up. Really important here to make sure that everything is an exact 90 degrees. I've already done the stretcher part, and I can show you how I check that it's an accurate 90 degree bend by using a small Lego block, and you can just insert that between, and you can then see whether you've got a 90 degree angle. Any angle off that you incorporate into the gearbox is going to affect the running, so it really is important that you take your time. Once you've bent it up and formed it correctly, just run a fillet of solder inside to make sure that it doesn't move. Then you want to do a couple of checks once you've got this stretcher piece done. First of all, take your chassis and make sure that it actually fits between the chassis frames. This one fits very nicely on the axle there. And secondly, get rid of that. Secondly, you just want to check the actual bushes themselves on the axle. So just insert that like so, give it a spin. I can hold that, there we go. And that's what you're looking for. A really nice free spinning axle within the bushes there. No friction, also no side play either, so tight but loose, if that makes sense. Not sure it does, but anyway. So this is how we bend up the frames. I just grab a pair of pliers and watch these tabs. You don't want to bend those tabs, they stay flat. So hold that, and I just use my fingers like so to slowly bend up. And the same on the other side. And you can get away with doing this with this material because it's quite thick. So now just check that's 90 degrees. Also use a set square, like so. So on that side I've overbent it a bit. It'll just come out just a twitch. It's all, quite unscientific, just trying to get it as accurate as we possibly can. Let's check this side. That's not too bad actually. And also, where's my Lego brick gone? There it is. Pop that in there. And see how it looks. Okay. So, a little bit more on that side. Perfect. Perfect. Alright, so in order to aid the construction of the gearbox, Chris gives you these little spacers. And once I move my hands out of the way, you'll see they go on those little tabs that we took off earlier. So this thing just goes on here just to check. You don't need to solder this one in place, but it's just a little check to make sure that it is square. And then what we do is solder in the 1mm rod like that. So when you join me again, I'll have this all soldered up and square, and we can actually go on to adding some gears. We're done with the soldering now, and we're ready to actually assemble the gearbox itself. In order to do that, you need to cut the steel shaft that's provided into length. Now, the way that I do that is to just measure the width of the gearbox itself. In this case, it was 10mm, and then cut this to about 11mm, so you've got a little bit of space either side. I just secure the end in a vise and then use a piercing saw just to make the cut nice and accurate, nice and quick, and no danger of it flying off and hitting you in the face. One thing that I've done after testing the motor is to fit the worm gear as well. Best way to do that again is probably in a vise actually. Just open up the vise, put the worm gear on the end and slowly clamp the vise shut, making sure that you keep the pressure perpendicular to the shaft of the motor. If you take a hammer and hit the worm gear onto the shaft, you're liable to damage the engine, the motor. These are quite sensitive, they've got the magnets in there and everything like that. So you don't want to bend the shaft in any way. So that's just a push fit on there. Once it's on, and you want about, 3mm of clearance there. It's all in the instructions, but about 3mm of clearance on the worm gear and the motor body itself. Sorry, just stepping back again one stage, I forgot to mention, when you're cutting this stuff, don't use your best pair of pliers because you will ruin them. It's really tough material. So, as I say, the saw's the best way to go. We assemble the gearbox in stages. You have a stage 1 idler, a stage 1 gear piece, and a stage 2. Stage 1 has 1 dot, stage 2 has 2 dots, and it's stage 1 that goes on first. Just check the orientation of the gearbox that you're using. Mine is going to be like so. So there's the rear of the locomotive, and then the gearbox is going to fit like so. So I need to have it in this sort of orientation, but you can have it in any orientation you like. You could have it like so. You can, angle it up even higher if you wish. All sorts of possibilities with this gearbox. So taking this and one of the shaft pieces, just insert that through like so. Stage 1 gear goes in there, and it's probably quite handy to have a pair of tweezers to do this. Make sure you get it the right way around. Push that through, and then we've also got this little spacer here. I found I just needed to ream that out ever so slightly to make it a nice fit onto the shaft. Push that through. It's a bit fiddly, you just got to try and line it up as best you can. There we go, that's coming in now. There. Okay, and that gear is now on there. Just check that rotates nice and freely, which it does. And then we can fit stage 2. Stage 2 doesn't actually need any spacer because it's held in by the previous one. So that goes up in there. Let's just adjust that. It's all a little bit fiddly. This one then comes out, so you've got to make sure that one doesn't come out. What we'll do once and this is why I leave a little bit extra room, once we've got all of the gear stages in, I just add a little bit of super glue on the end of each shaft just to secure them in nicely. Let's go in like so with that, and this guy goes in there. Oops, need about 4 pairs of hands to do this. It's a little bit fiddly. Let's just balance that on there. Needs to go under there like that, that's it. So it helps to have a nice pair of tweezers. Once it's in, it kind of holds itself. There we are, that just clipped in there nicely. Push him through, and that's it. So again, just check that they rotate freely. They do. I'm just going to work on now, attach this final stage, and then we'll be able to test the gearbox and hopefully get it up and running. So, believe it or not, we're actually pretty much done with this now. I've carried on and assembled the axle onto the rest of the gearbox like so, just following the instructions. It's all pretty straightforward. You just maybe need an extra pair of hands to balance on the parts before you put them through. And for reference, there's a couple of really handy diagrams on there, just on the instructions, just to show that you've got the alignment correct. So Chris provides all these. There you go, highlevelkits.co.uk. Chris provides all these instructions with the kit, so you can check and make sure everything's okay. Top tip, when you're just doing the testing phase, as I am now, just secure the shafts on with a little bit of masking tape, just to stop everything falling out. And then once you're happy with everything, I like to put just a little dab of super glue on there. But I've attached the motor, all the gearbox is in, so let's get my little test rig, clip on the crocodile clips, and give it a little whirl. How's that, eh? That's not bad at all, is it? Considering that's had absolutely no running in whatsoever, I'm pretty happy with that. There we go, full speed, nice and smooth, right the way down. Like that, and then the other way as well. Even smoother. Bearing in mind that's had absolutely no running in, and I honestly, I haven't done any tweaking to this, I haven't done anything to it. That's exactly as I built it. If I wasn't filming, I probably could have got that done in, 20 minutes, half an hour, and that's the result. So run that in, probably half an hour in each direction, maybe a little tweak. If you do find things are off, it might be worth just twisting ever so slightly, just to sort of try and ease any tight spots. But if you take your time and build it as per the instructions, which are provided and are very good, you shouldn't have any problems at all. I'll get this finished off and then we'll summarise. Well, there you have it. That's how you build a gearbox for a kit-built model engine. Hopefully I've shown in the video that it's not as difficult as you might initially think. Especially if you build a good quality gearbox, then you don't need too many specialist tools, and there's only a little bit of soldering, so it shouldn't be too hard. Just follow the instructions, take your time, and if you really do have any problems, then you can always give Chris an email at High Level, and I'm sure he'll be able to help you out. The other thing about building a gearbox like this is that you get something that's custom for your specific project, and I guarantee you'll be really pleased with how smooth and how quiet the gearbox is in comparison to something that you might have from Hornby. Well, I hope you enjoyed the video. If you like it, please subscribe, and if you've got any questions, don't hesitate to ask. In the meantime, please enjoy your modelling. See you soon. Bye bye.